Moving right along into our next example, we're going to integrate negative 2x plus 4 over x squared plus 1 times x minus 1 quantity squared. Okay, so again, working with just the integrand first and breaking it down using our partial fraction decomposition. Now, notice what you have in terms of your factors. It is already factored, which is nice. This first factor does not break down. So this is considered an irreducible quadratic factor. You can't factor this first x squared plus 1 factor. So irreducible. And so it's going to stay quadratic in our denominator, which is going to affect how we write our numerator. So our integrand here is going to be broken apart into a fraction over x squared plus 1. Now the next term is going to have the next factor in it from the denominator, x minus 1. Actually, we don't need the parentheses there necessarily. But then we do need a third term here because we have this linear factor squared. So whenever, and we talked about this in a previous video, whenever you have a factor repeated, you have to write it in the denominator once, and then you keep going until you've addressed how many times you have it. So what I'm saying here is like the fact that it's repeated twice, you have x, this quantity squared, you need to write it once and then write it again squared. If this was to the third power, we'd have another term with x minus 1 to the third power and to be our fourth term here. Okay, so I mentioned because this is an irreducible quadratic factor, our numerator is going to be linear, and this is because linear is first power, 1 degree less than squared. So if I have an x squared in my denominator, I need an x to the first power in the numerator, and so we can write that as ax plus b. So instead of just writing like x to the 1 and by itself, there might be a number in front of x and there might be some constant. So I just address that like this by writing ax plus b. This term is linear as far as x goes, x to the first power, so we just need a constant, so c. Over here, this is also linear, x to the first power, so d for our numerator. Okay, so we'll break this down as far as what a, b, and c, and d equal. And so remember how this works. You are going to multiply by the LCD. And so officially what's happening here is this integrand equals these three fractions added together. So when I multiply by the LCD, all the denominators are going to divide out. So what we have, if you consider this integrand on the left side of your equal sign here, when you multiply this integrand by the LCD, in this case the LCD is this denominator, then all that's going to be left on the left side is negative 2x plus 4. Okay, so this integrand multiplied by the denominator, you're left with just the numerator. When you multiply the right side of your equal sign by the LCD, think about what would happen. When I multiply by this LCD, this denominator, the x squared plus 1 is going to divide with this x squared plus 1. So I'm going to be left with ax plus b times the other term that I multiplied by for my LCD. So times x minus 1 quantity squared. Moving right along. The middle term here, when you multiply by the LCD, so let me just make it really clear. I'll put it in another color so you can see what happens on this one. When I multiply this term by the LCD of x squared plus 1 times x minus 1 quantity squared, one of the x minus 1 factors that's being squared here, one of those is going to divide with one of these. And so what's left is c times x squared plus 1 times 1 of the remaining x minus 1 factor. Okay, and so the same LCD, multiply it by the last term here, and then the x squared minus 1 x minus 1 quantity squared divides out, and you get d times x squared plus 1. Okay, so now let's keep going with our algebra. Let's start foiling some stuff out. I'm going to focus on the terms with x in them first, as far as that came from our denominator, and then I'll go ahead and keep foiling. So ax plus b, if I square this out, this is going to be x squared minus 2x plus 1 from foiling that out. Over here I have a plus c. I'm going to FOIL these two. So this is going to be x cubed plus x, actually, nope, sorry. So x cubed minus x squared plus x, and then minus 1. And then in the back, let's go ahead and just distribute. So d squared, sorry, d times x squared plus d. All right, now I'm gonna go ahead and keep going, and this time I'm gonna FOIL out this one, and then just distribute the c here. So from this one, when I start to FOIL this out, I have ax cubed from the first term, and then I'm gonna go with b times x squared. Okay, so bx squared there. And then negative 2a times x, so x squared. So negative 2a x squared. And then negative 2 times bx. And then we have ax times 1. And then b times 1. All right. All of that was from the very first term over here. So I'm just going to keep going, and let me just go down to the next line. This is plus c times x cubed minus cx squared plus cx minus c, last terms, plus dx squared plus d. Okay, so all of this equals the left side of our equal sign. And so I am going to rearrange it in just a moment, because we're going to match up what we have on the right side with what we have on the left side. So notice what you're working with on the right side. You have x cubes, you have x squareds, you have x's, and you have just constants. On the left side, is the highest power on x that we see is just x to the 1. So here's how I'm going to rewrite the left side, and hopefully this makes sense. 0x cubes are on the left side, and then 0x squareds are on the left side. And then minus 2x is here, and then plus 4. All of that's the left side of my equal sign. And then I'm going to line that up with the right side. Okay, so let me color code so you can keep track. We have x cubes here and x cubes here. So I'm going to factor out the x cubed to the back of those terms. And we have a times x cubed, so plus c times x cubed, so a plus c is what we factor there, times x cubed, to get those two terms. And that's going to end up lining up with this term here. Okay, let's go on to the next one. Look for x squared, so bx squared, negative 2ax squared, negative cx squared, and dx squared. Okay, and that's going to line up with 0x squared from here. So next terms, I'm going to factor out the x squared from all 4 that I just underlined, and I'm going to put the x squared in the back. And so we have b times x squared, so factor out the x squared, b minus 2a minus c plus d. All right, and that was all of the coefficients on an x squared term. And then let's go to the terms with x in them. So negative 2bx, ax, cx, and that looks like all of them. And that's going to line up with this one here. Okay, just to save some space, I'm going to just move down here. This is going to be factoring out my x from the back of the terms in red. So we have a minus 2b when we factor out x plus a, let me give myself more room, plus c. And then the x came out of those. You can bring it back in to see that you'll get those 3 terms. And then the very last part, I ran out of color, so we'll stick to black here. The 4 is the constants. So we have b and negative c and d are all that's left. So those are the constants. So we have plus, and let's just group them, b minus c plus d. Okay, and those match with the constant over here. Let me underline what we had in red real quick for this term. Okay, so all of this algebra was to get to a system of equations that's going to allow us to find a, b, c, and d. Okay, so let's start our system of equations from what we have going on here. Equation 1, the coefficients on x cubed match on the right side with the coefficients of x cubed on the left side of our equal sign. So there was actually 0 x cubes originally on this left side. So that means 0 is the coefficient on x cubed. So 0 is the same as this coefficient on x cubed, which is a plus c. So that's our first equation. Moving on to x squareds. There was no x squareds initially on the left side, so there was 0 x squareds. So if we match that up with our right side, these coefficients on x squared, which we factored out from up here, all these coefficients on x squared equals 0. So we have 0 equals b minus 2a minus c plus d. Equation 3, we have the coefficient on x was negative 2, and so the coefficients on x equal this coefficient here, negative 2. So we have negative 2 equals negative 2b plus a plus c. And then our last equation for our system of equations is that the constant 4 equals all the constants that are left over. So 4 is the same as these three constants. So 4 is b minus c plus d. Okay, so we have a system of 4 equations, and this is actually what we need to do because we had 4 unknowns. So whenever you have variables you don't know, you have to have that number of equations or more to find out those variables. We had 4 variables, a, b, c, d, we didn't know, so we had to have at least 4 equations. So this is good. So we're going to solve this system for a, b, c, and d. Okay, so we're solving this system of equations for a, b, c, and d. You can use any method you like. If you know matrices, it might actually work out pretty well, but not everybody's familiar with that. So I'm going to show you with elimination. Now, on this one, you kind of have to be strategic. You have to think about which equations have the same variables and work with those. But the very first thing I noticed with this system is that equation 1 only has 2 variables, and so I can modify this and solve for one of them in terms of the other. So I'm just going to say that a is negative c from equation 1 by subtracting c. What that's going to let me do is start to get rid of having so many variables in equations. So I'm going to just take what I found in equation 1 and let's just use it in equation 2. So we're going to use that fact and plug it right into equation 2, and let's see what we come up with. So we have 0 equals b minus 2a, but we just said a is the same as negative c. So negative 2a, and then minus c plus d. Okay, and let's make this look a little better. So we know that 0 is b, and then this is going to be plus 2c minus c. So that's plus c plus d. Okay, so based on what we have now, we have an equation with b, c, and d in it. It is officially a new equation from our list, so to keep myself organized, I'm going to call it 5, equation 5. So if I can look at equation 5 and see if I can line this up with anything that has a b, c, and d in it from what I already have, if you look at equation 4, it also has b, c, and d in it. So this is a good way to go. I'm going to combine 4 and 5, and if you look at them, you could actually just add them to get rid of c because it's positive c and negative c, so you don't have to do much other than just add 5 plus 4. So I'm going to go up here, I'm going to say equation 5 plus equation 4. Okay, so let's rewrite that really quick. So 0 equals b plus c plus d from equation 5. 4 was 4 equals b minus c plus d. And adding straight down, I get 4 equals 2b, the c's eliminate, plus 2d. Okay, let's keep track, call this equation 6. So if I look at this, I have b and d in it. None of my other equations have exactly just b and d in them. So let's see, let's go back and use 1 again, our modified version of number 1, and let's substitute it into equation 3 this time and just see if we can get rid of this a in equation 3 as well. So just modifying equation 3 by plugging in 1 into it, we have negative 2 equals negative 2b plus a is negative c from equation 1, so negative c, plus c. Oh, this is really good. So then we end up with negative 2, the c's add up to 0, equals negative 2b. 1 equals b. So if you saw that earlier, you could actually do that whenever you see it. Now we have a variable value, so this is really good news, so we can start plugging it in and finding the other ones. Let's go back. Now, if you go right into equation 6, you know one of the two variables in equation 6, so we can find d. So from equation 6, 4 equals 2 times b, but we just found out b is 1. So plus 2d. So if you solve this, you're going to get that d is also 1. All right, 2 down, 2 to go. We have b is 1, d is 1, and let's see where we can plug back in. If we take these and we go back into equation 4, which had b and d, we can find c. So I'm going to plug into equation 4 now. Equation 4 was 4 equals b, which is 1, minus c plus d, which was 1. And so that tells us that c is negative 2 if you solve that for c. Okay, last one. We have to now find a, and we know from the first equation that a is negative c. So from equation 1, we know that a is negative times negative 2, so that's 2. Okay, we found them. So quite a bit of algebra, but we found a, b, c, and d. We're going to plug it right back into our partial fraction decomposition, and then after all of that, we get to integrate. Alright, I just wrote what we came up with for a, b, c, and d, and let's go ahead and plug this right back into our original integral. So originally we had this one single term for our integrand, but we broke it into 3 separate fractions. So I'm going to go ahead and break that into 3 separate integrals. And so our original integral becomes a was 2, b was 1. So this is 2x plus 1 over x squared plus 1 dx. Next term, we have c was negative 2, so this is integral of negative 2 over x minus 1 dx. And then our last term here, we have the plus the integral of d, which was 1 over x minus 1 quantity squared. Let's move this out of the way now, dx. Okay, and so the hard algebra part is over. The rest is going to be us using our integration techniques. So on the first one, we're going to use u substitution. If you let u equal the denominator here, x squared plus 1 du is 2x dx, and so that's going to give us part of what we have up here, but we can separate this into 2 terms. So let me work this one out. So this first integral, let's separate it first actually. So you see what's happening. This is the same as 2x over x squared plus 1 dx plus 1 over x squared plus 1 dx. And so the u substitution can be used for the first part. Now on the next one, the second integral here, you can think of it as using u substitution, but since the derivative of the bottom is just 1, you don't really have to even do that, and you could just jump right into the integration. So it's going to be ln, it's going to have ln in it. And then over here, you're just going to have, you can call this u as well, and again, it's going to be the same situation where the derivative is 1, so you don't really have to even show that part, but let me show it for you. If you say u is x minus 1, du is what I was saying, it's just 1 dx. And so when you substitute, it really doesn't make a big difference, and you have that this is going to be the integral of 1 over u squared, which is the integral of u to the negative 2. So you're just using the power rule on this one. Okay, so if you want to, pause this so you can work out the integration part of it, and then I'll show you what you're going to get in just a moment. Okay, so on the first one, you have just 1 over u, so hopefully you got that this is just ln u, but u was x squared plus 1. The second one, now this one, you might have looked at this and thought, well, what do I do here? If I try u substitution, that's not going to work. There's no derivative. but this is actually a derivative that you know. So remember what the integral is asking you. It's saying which function has a derivative that looks like this, and this is familiar, hopefully. This, going back to calculus 1, this integrand here was the derivative of tangent inverse. So this is actually, this integral value is tangent inverse of x. So let's write it down here. So this is plus tangent inverse of x. And then over here, this is just 1 over this argument, so it's going to be negative 2 times ln of that argument. So ln x minus 1. And then over here, using your power rule, this is u to the negative 1 over negative 1, but there's already a minus out front, so that becomes a plus. And then this u to the negative 1 moves down, and it becomes positive u on bottom, but u was x minus 1. All right, plus c. Okay, there it is. A little tricky, it had a few interesting parts to it. Just take your time, stay organized on these ones, because there was a lot of algebra, and then on this one specifically, there was a couple of different integration techniques that we use. But hopefully this helps.